right, let's go ahead and get started. The title of this worksheet is Mole Particle Conversions, and you are going to need a calculator with scientific notation capabilities. So if you don't have one of those available, now would be a good time to pause the video and just make sure that you have access to that. So what do we mean by a mole? Well, as it turns out, in chemistry, we deal with very, very small particles, things like atoms and formula units and ions. So it wouldn't really be convenient to talk about a pair of atoms or a dozen formula units or ions or anything like that because they're so small. But we're going to need a new unit, and the new unit we're going to use is called the mole. So it's just a number, it's a counting number, but it's a very, very big counting number. It's this number. It's 6.022 times 10 to the 23rd. And we're going to commit that number to memory because it's going to come up again and again. But as you can tell, it's a huge, huge number, almost unimaginable. Remember, there's 3 zeros in 1,000 and 6 in a million. We've got 23 zeros here. So it's a very, very, very large number, but one that we'll need for conversions from moles to particles and back. Now let's talk a little bit about what we mean by particles. Well, a particle can mean anything we want it to mean. It can mean a pretzel or it can mean an elephant, but more than likely it's going to mean an atom or an ion or something very, very small. All right, so let's take a look at this first problem here. It says how many atoms are in 4.00 moles of helium? So let's start with what we know. So we've been told that there are 4.00 moles of helium, and we're being asked about the number of atoms. So this is clearly a conversion problem. But how do we convert from moles to atoms? Well, we're going to start with what we know. And what we know is 4.00 moles of helium. And so I'm going to write that just like that. So 4.00 moles of helium. Now, I'm going to put that number over 1 just to hold the place, to distinguish between the numerator and the denominator. And then what I'm going to do is I'm going to multiply essentially by 1. How am I going to do that? Well, what I'm going to do is a little trick in which what I'll do is whatever unit is in the upper left-hand corner goes into the lower right-hand corner underneath the next line. That will ensure that these two units will cancel. The unit that goes in the upper right-hand corner is the unit that I'm looking for. In this case, it's atoms of helium, just like that. Now, I've committed to memory this number, 6.022 times 10 to the 23rd atoms per mole. So that many atoms per 1 mole, and now I'll start the cancellation process. Moles of helium will cancel. That will leave me with atoms of helium, and that's what I want. So what I'm going to do now is I'm going to multiply these two numbers. So make sure you know how to enter 6.022 times 10 to the 23rd. If you don't know, ask me or ask a neighbor. But you have to know how to enter this into the calculator in order to multiply it by the 4. And so what I get is this number. I get 2.41 times 10 to the 24th. Now let's talk a little bit about significant digits. Notice I've got three significant digits on the 4.00. So 3 significant digits here. And I've got 4 significant digits on the 6.022. So I'm going to take the lesser of these two, which is 3. So regardless of what the calculator tells me, I'm going to take 3 significant digits because I've got 3 significant digits here. So 2.41 would be my, times 10 to the 24th then, would be my answer. And I'll leave it at that number. So that's my final answer. That's number 1. Let's look at number 2. Number 2 says a coin contains 0.800 moles of silver. How many silver atoms are in the coin? So this is what I've been given. I've been given 0.800 moles of silver, and I'm looking for the number of silver atoms, right? I'm looking for the number of silver atoms. So I'm going to start with what I know. What I know is 0.0800 moles of silver, Ag. I'm going to place that number over 1, just like that. That holds the place. And then what I'm going to do is I'm going to make another line, and whatever unit's in the upper left will go right here. And I have moles of silver right there. Now what I'm going to do is I'm going to look to see what unit that I'm looking for. In this case, I want to know how many atoms of silver. So I'm going to put Ag atoms right there. That's how many I'm looking for atoms of silver. And I know from the previous problem that there are 6.022 times 10 to the 23rd atoms per mole, just like that. Now I'm ready to cancel. Moles and moles of silver are going to go away. That's not by accident, that's by design. And I'm ready for the calculation. I'm going to multiply 0.800, remember 3 significant digits here, by the 6.022 times 10 to the 23rd, 4 significant digits. I'll take 3 significant digits, and this is the answer that I get. I get 4.82 times 10 to the 22nd atoms of silver. And I'm done. And that is my final answer. Okay? So that's number 2. Let's take a look at number 3. Number 3 says a neon sign contains 2.01 times 10 to the 21st atoms of gas. How many moles of gas of neon are in the sign? So this is the number of moles of atoms of gas. I'm looking for moles this time. So I'm going to start with what I know. In this case, what I know is this number, 2.01 times 10 to the 21st, and that's atoms of gas. Just like that. Then what I'm going to do is I'm going to put that over 1 and multiply it by, remember, whatever unit's in the upper left-hand corner goes in the lower right-hand corner. So I have atoms of neon here. And I'm looking for moles, so I'm going to put moles of neon right there. And we'll ask ourselves the question, how many atoms are there in 1 mole? Notice this time the 6.02 times 10 to the 23rd goes on bottom. That's going to mean when I do the calculation, I'm going to divide these two numbers, not multiply. So remember, this unit and this unit will cancel, and I'm going to be left with moles of sodium. Moles of sodium, just like that. So when I divide those two numbers, again, make sure that you know how to enter those numbers into the calculator. If not, come in for tutoring and I'll help you. Or better yet, you can even ask your neighbor. So 2.01 times 10 to the 21st divided by 6.02 times 6.022 times 10 to the 23rd. Let's make that 6.022. Okay, let me just slip that 2 right there. Times 10 to the 23rd will tell me the numbers of moles of neon. And I get this number, 3.34 times 10 to the -3 moles of neon. That's to the correct significant digits, so I'll make that my final answer. We've got 3 significant digits here. We've got 4 significant digits here. So I should have 3 significant digits in my final answer, and I do. Okay? All right, let's go on to number 4. A cup of water contains 13.9 moles of water. How many molecules of water are in the cup? So I'm looking for molecules, but I've been given moles. So I'm going to start with what I know. In this case, I've got 13.9 moles of water. Just like that. I'm going to put that number over 1 and then multiply it by, remember, whatever unit's on upper left goes on the lower right. So we've got moles of H2O right there. In this case, when we talk about a particle, we're not talking about atoms, we're talking about molecules, or yes, molecules of water. So on top, we're going to have molecules, because that's what I'm looking for, of water. And how many of those water particles are there? Well, 6.022 times 10 to the 23rd water molecules per mole. So we should start getting used to that number by now. Now notice this unit and this unit are going to cancel. And what's going to be left is molecules of water, which is exactly what I want. Both of these numbers are on top, so I'm going to multiply those two numbers. And when I do, here's what I get. I get 8.37 times 10 to the 24th, and that's molecules of water. Three significant digits on the 13.9, four significant digits on the 6.022. I should have three significant digits on my final answer, and I do, so I'm satisfied with that answer. Done. Let's go to number 5. A box of table salt contains 1.287 moles of sodium chloride. How many formula units of NaCl are in the box? So remember that NaCl is an ionic compound that is composed of formula units, Na and Cl, for example, in this case. Now, in the actual compound, in the actual substance, we don't see just units of Na and Cl. We see NaCl followed by NaCl followed by and so on until, well, the entire substance is spanned, right? But in this case, we're just talking about the formula unit as a particle. So what I'm interested in here is what I'm looking for and what I'm being given. I've been told that there are this many moles of formula units. And I'm looking for the number of formula units in the box. So what I'm going to do is start with the number I've been given. In this case, it's 1.287 moles of these formula units. In this case, NaCl. I'll put those over 1. And then what I'm going to do is I'm going to make another line, just like that. Whatever unit's in the upper left-hand corner will go in the lower right-hand corner. So I've got moles of NaCl right there. On top, I want to know the number of formula units. So I'm just going to put formula units of NaCl, just like that. How many are there? Well, this many. 6.022 times 10 to the 23rd formula units per mole. Now, I can cancel. That will cancel with that, not by accident, but by design. And I'm going to be left with formula units. That's what I'm looking for. I'm going to take these two numbers now. I'm going to multiply them. And the number that I get is this. 7.750 times 10 to the 23rd. And that's formula units of sodium chloride, or NaCl. Let me just do a quick check of significant digits. 4 here, 4 here. I need 4 significant digits in my answer. I'm satisfied with that answer, and I'll move on. Last problem. Let's take a look at number 6. A vitamin contains 2.9 times 10 to the 20th iron atoms. How many moles of iron are in the tablet? So I've been given this number of atoms, and I'm looking for moles. I'm going to start with what I know. In this case, it's 2.9 times 10 to the 20th iron atoms, right? And what I'm going to do is place that over 1 to hold the place. I'm going to use this unit down here, right here. So I have iron atoms. And on top, I'm looking for moles. So I have moles of iron right there. Notice this time, the number 6.022 times 10 to the 23rd goes on the bottom. This cancels with this, and I'm going to be left with moles of iron. I'm going to divide these two, and when I do that, I get this number. 4.8 times 10 to the negative 4th, and that's moles of iron. 2 significant digits here, 2 significant digits here. I should have 2 significant digits there. That's my final answer. Thank you very much. I'll see you on the next one. Bye-bye.